We've covered a lot of ground already. We've questioned the notion of number and the peculiar, troubling question of what one would be without another, given that reality is continuous for an embodied being. I have to speak from the position of an embodied being all the time here in these videos, which means there are certain abstractions that are not available to me. But abstractions are our currency, aren't they? We use abstractions all the time. We've honed in on the question of measurement and its central role in physics, which makes use of a single trick with respect to the notion of light in order to achieve physical measurement. And we've tried to sort of ignore the complexities of all the other differentiated and articulated sciences so that we can concentrate on what the esoteric discipline of physics, now not physics as intangible, touchable stuff, but the theoretical physics, how that must appear to an embodied being who has a different relationship to space and to light. Because physics, as far as I know, is done by embodied beings. You see, physicists are people, somewhere between 1 and 2 meters high usually. And they use their imaginations a lot. So before we get on to more embodied questions, I've been promising what I just wanted to say, devote confidence in the French imagination, really, I suppose, because it's very useful, but to remind ourselves that it is an imagination. And for that we're going to turn not to a Frenchman, but to Johannes Kepler. And quite who people in history are and what country they lived in seems a bit irrelevant, thinking things through from this point. But Kepler was a German, and we associate him, if you read up your Wikipedia, you'll find out that he's the guy who taught us that it wasn't circles we should be looking for in the orbits of the planets, but ellipses. A very strong geometrical intuition there, shifting many, many centuries of spatial thinking in which space was conceived of in terms of circles and spheres. How did this come about? Well, the funny thing about Johannes Kepler was he mainly used his imagination. Telescopes were only just being invented around that time. Remember that the tubes that were so going to greatly affect people's imagination and the way they thought about space in the large and space in the small. Well, Kepler did most of his foundational work without the help of any telescopes whatsoever. Later on in his life, he got access to what we would now consider to be a data science lab run by Tycho Brahe, and he adjusted his imaginative constructions using the little bit of data he had on Mars. But for the most part, Kepler was just using his big-brained imagination to think about space, and he did so very, very well. We played some games in the last video, which took the geometry of two-dimensional space and started thinking in 3 dimensions. And for that, it was necessary to introduce these solids and position them in space and look at them and consider them with respect to the body. Now, I'm an amateur at this. Johannes Kepler was the best in the world at this. So just to recap briefly, we started with this contemplative figure of a circle in which a square or a regular-sided polygon has been inscribed, and we noted the role of the red line. These are figures which will stay with us continuously, the circle indicating continuity and perfection, and the square or the many-sided figure standing for that which can be counted, for multiplicity. Now, that's in 2 dimensions, that's an easy thing to play with, and we started playing mind games last time in 3 dimensions. I've illustrated that on the screen there, but actually what we were doing was imaginatively placing spheres inside and outside these platonic solids. We placed a sphere inside and outside the octahedron, and we placed a sphere inside and outside the cube, and we found lovely relations. Now, Kepler did this, and he did this with absolute imaginative genius. Shown there is a print which he published, which illustrates his thinking about space in the big, what we now call the solar system. And to show you the way that Kepler was using his spheres, imagine, if you will, the orbit of the Earth is a sphere, right? And then we're going to put one of these, we're going to put this guy inside the sphere. So we're going to put not a square, not a cube, not an octahedron. We're going to put this guy, this 20-sided, isn't it? 20-sided icosahedron. We're going to put that inside and then blow up a sphere inside that. So we've got a sphere around this and a sphere inside that. And Kepler intuited that the orbit of Venus would correspond to a sphere inside this if the sphere outside it was the Earth. So using the Earth as an anchor, he placed, as it were, and this as his tool, he placed the orbit of Venus inside there. And then he went further. You take the orbit of Venus, that's a sphere around my octahedron, now you put a sphere inside here and you blow that up. And that sphere would correspond to the orbit of Mercury. So that is moving in towards the lesser planets, closer to the Sun. Now we're going to start again, and we're going to work outwards. We're going to take a sphere, which is the orbit of the Earth, and we're going to put something around it. We're going to put this no, not that one. This one, the dodecahedron. So we place the sphere of the Earth around inside this, maximally, and we contract another sphere, and that sphere would give us notionally the orbit of Mars. And you take the orbit of Mars, which is a sphere, and you take your dodecahedron, so orbit of Mars is in the sphere inside this, and you contract the sphere around the outside, and lo and behold, that's going to give you, in Kepler's imagination, the orbit of Jupiter. And then you take the orbit of Jupiter, because why not, and we've got 5 solids to play with, and you place it inside the cube and blow it up, contract another sphere around that, and you get the orbit of Saturn. That was Kepler's view of the likely arrangement of the planets. It fitted his intuitions. These geometric intuitions are very strong, and thinking in three-dimensional space with these is very powerful. Kepler was brilliant at this. He even came up with extensions to the Platonic solids no one had ever thought about. So here you see Kepler's vision of a nesting of spheres with these Platonic solids organizing the distances. In this one you can see in from Mars through the Earth in towards the Sun. And then he went and did some data science. He got a little bit of data from Tycho Brahe and fixed up the Mars juggle things. And now we have a very robust model of the solar system that lives in our heads. It's an abstract model of the solar system, and its birth is in Kepler's imagination. There's a lot of imagination in physics. There's more imagination than you might think. So we've been, speaking from an embodied position, I've been wondering about who these physicists are, what they think they're doing, as they stand with their bodies on the Earth. Now they're using their imagination fantastically, but in physics, space-time plays such a role that is taken as it were, the fabric, the pre-existing fabric of things. But space-time is a notion that comes from physics, justified by its power of measurement, but produced using this one weird trick of freezing, making the assumption that it makes sense to talk of the speed of light in a vacuum. That licenses measurement, and physics acts as if the unit with which space is measured, the meter, were fully abstract. Now we've seen reason to suggest that measurement, even of space, is a matter of finding an appropriate middle term between something much smaller and the project, that is, that which one wishes to measure. And this is where we're going to go in the next few videos now. We're going to explore what it is to be an imaginative being with a single body, thinking up such things. But because we're coming from 1E cognitive science, we're going to pay attention to the body, and we're not going to indulge in fantasies about the brain producing things. This is a plastic brain picked up at a neuroscience conference, and it's got googly eyes on the front. It's a most wonderful tool for thinking about brains because it's not a real brain. Most of our fantasies about brains are not about real brains. A real brain would be a thing in a body where it's integrated, and it makes as much sense to talk about consciousness perceptions in terms of the brain as it does in terms of the kidney. We'll be coming back to this, and we'll be wondering how to understand the body, knowing some of what we know now about the relationship between physics, measurement, light, space, and the questions that necessarily arise for an embodied being for whom some abstractions are simply not available. Oh, looks like there's more to do around here. Okay.